Problem number 16. In the given figure, block A of mass 1.6 kg slides into block B of mass 2.4 kg along a frictionless surface. The direction of these three velocities before and after the collision are indicated. Here I stands for initial, F stands for final. The corresponding speeds are VAI, which is equal to 5.5 meter per second, VBI, which is equal to 2.5 meter per second, and VBF, which is equal to 4.9 meter per second. Now we have to find the answer for these three questions. In the first part of the question, we have to find what is the final speed of the block A, which is VAF. That thing we have to find first. And then we have to give the answer for the second part after the collision takes place. So the block A is moving right hand side or left hand side. And then we have to give the answer, is this collision is elastic or inelastic? So let's we answer one by one. I already wrote the given first. So the mass of the block A is 1.6 kilogram. The mass of the block B is 2.4 kilogram. And VAI, that means the block A initial speed is 5.5 meter per second. That means this value. And likewise VBI, which is 2.5 meter per second. So this value, the speed of the VBI is 2.5 meter per second. And VBF, so after the collision, the block B final speed is given as 4.9. So what we have to find? So we have to find what is the final speed of block A. So for this, what we have to do, we have to use the conservation principle. So I have to apply the conservation formula, the conservation of momentum formula for each and every block separately. So that is nothing but the law of conservation of momentum. So we know the formula for momentum. So the formula for momentum P, which is equal to mass multiplied by velocity. So I have to substitute this formula for each and every block. So let's we consider before collision. So I'm going to apply this formula for this one, and I am going to apply the same formula for this one and this one. So that means the first part is before collision, the second part is after collision. So let's we substitute the formula. The way we have to write the formula for before collision and after collision. So how can we write? MA multiplied by VAI plus second block momentum. So MB VBI, which is equal to MA VAF plus MB VBF. So that means this is before collision, this one is after collision. Clear? Now we have to find the answer for VAF. So what I am going to do, first of all, we can rearrange this equation. I am going to keep this term here. I have to bring this term to the left hand side. By that, what we'll have, the equation is remodified as MA VAF, which is equal to MA VAI plus MB VBI minus MB VBF, and then we are going to find the answer. So I have to move this MA to the right hand side of this equation. So by that, the equation again is remodified as VAF, which is equal to MA VAI plus MB VBI minus MB VBF divided by MA. So now we are going to substitute the value here. So as we already have all the values, so better we can substitute the values one by one. What is the mass of the first object, which is 1.6? Better I can note down the answer values again. 1.6, 2.4. Okay. So I'm going to substitute these values here. MA value is 1.6. So 1.6 multiply with VAI, which is 5.5 plus MB, which is 2.4 multiply with VBI, which is 2.5 minus MB, again 2.4 multiply with VBF, which is 4.9 divided by MA, which is 1.6. Answer for VAF. So I have to use my calculator. Let's see what is the answer. 1.6 multiplied by 5.5 plus 2.4 multiplied by 2.5 minus 2.4 multiplied by 4.9 divided by 1.6. I got the answer here as 1.9 meter per second. 1.9 meter per second. Now we have to give the answer for the B part. So what they ask in the B part, after the collision, whether the block moves left direction or right direction. So for getting the answer for B part, you have to see the answer for the first part. What is our answer in the first part? We got the positive value of 1.9. That means the block B, which is moving right side. Why? We got the positive value here. If you got negative value, you have to give the answer. The block A is moving to the left direction. So here, based on the answer of the first part, we got the positive value of 1.9. So I have to give the answer. The block moves, it moves right side. Clear? So that's the reason I told you earlier, for getting the answer for part B, we have to get the answer for part A. So based on the answer what we get from the part A, we have to give the answer for part B. And also part C, they asked, we have to give the detail whether the collision is elastic or not. So what we studied in the theory class, through only one principle, we can confirm whether the collision is elastic or inelastic by using the conservation of kinetic energy. So what we have to do, we have to use the conservation of kinetic energy for getting the answer for the collision. So I have to apply the kinetic energy for each and every block separately. So let's go back to the diagram. So I have to write the kinetic energy for the first block initial. I have to apply the kinetic energy formula for the second block initial. Likewise, we have to apply separately. So after you find what you have to do, you will get some details. So if you got the left hand side and the right hand side same answer, then you have to give the answer that collision is elastic. Suppose if you got different answer, then the collision will be inelastic. So let's substitute the formula first. For finding the collision which is elastic or inelastic, what we have to do? We have to use the kinetic energy principle. Clear? So what is the kinetic energy formula? V squared. So let's substitute the formula here for the first part. Half MA VAI square plus half MB VBI square, which is equal to half MA VAF square plus half MB VBF square. So that is nothing but I apply the kinetic energy formula for each and every block for initial, before collision and after collision. Now you can see we are going to substitute the values here. When you substitute the values here, because now we have all the values for VAI, VBI, VAF, VBF, and also we have the mass of the block A and block B. So once you substitute, you will get some answer in the left hand side. Likewise, you will get some answer in the right hand side. If both left hand side and right hand side you will get the same answer, then you have to give the answer the collision is elastic. Suppose if the left hand side and the right hand side answers are different, then you have to give the answer the collision is inelastic. Okay, let's see what is our collision, whether it is elastic or inelastic. So I'm going to substitute the value here. So half the mass A value is 1.6 and then VAI, which is 5.5, right? So 5.5 square plus half multiplied by the mass block B, right, which is 2.4 multiplied by VBI, which is given in the question, which is 2.5 square. Likewise, I have to do the same thing here, which is 1.6 multiplied by the answer VAF. We got 1.9, right? 1.9 square plus half 2.4 multiplied with 4.9 square. So let's see what is the answer in the left hand side and the right hand side. Multiply by 1.6 multiplied by 5.5 square by 2 plus 1 multiplied by 2.4 multiplied by 2.5 square over 2. I got here as 31.7. So when I solve this part, I got here as 31.7 joules. So let's we see the right hand side. So what we are going to get for the right hand side? 1 multiplied by 1.6 multiplied by 1.9 square divided by 2 plus 2.4 multiplied by 4.9 square divided by 2, we got 31.7. Now you can see the right hand side value and left hand side value. We got 31.7 joules here. We have 31.7 joules. That means the kinetic energy initial and final is exactly the same. So what we studied in the theory, if your initial kinetic energy must be equal to the final kinetic energy, then the collision is elastic. Suppose if you got different answer, then the collision is inelastic. So what is the answer for this question? The collision is elastic. So this is the answer for the third part. How we gave the answer? Based on the answer what we got after we substitute the formula for after we substitute the values in the formula for kinetic energy. We got same answer initial and the final. So that's the reason we say the collision is elastic here. That's it. Thank you.